This is a cast iron part off of a Bridgeport milling machine, and this is a really common failure. There's a little screw that goes down into this hole and it gets over tightened, and then this bit gets broken off. So let's get this... Okay, you got me. I was being an idiot and I broke it when I was getting it out of the machine. Now, because this part's so intricate, we've got a threaded feature here and a couple of counterbore holes. Rather than welding this and risking damaging those features, what I'm going to do is carbon fibre composite repair. This is all now nice and clean, and we've done a bit of grinding to roughen up the surface so that the adhesive's got something to grip onto. And we've got a really nice fit up of the original part to the point that I can get the original screw that goes in here and screw it back in down the broken thread, and that's a really nice fit up. So the next step is to get a little bit of super glue and put it on this original brake line and glue the bit back together. Now, the super glue isn't there for its structural performance in the repair, it's just there to temporarily hold the part in place while we do the actual repair. What I don't want to happen here is for this little hole to get all full of super glue. So what I'm going to do is put a little bit of oil on this screw and screw it into the hole. While this is drying, we need to make some little dams to go in here and in here to stop the epoxy flowing when we do the repair. So let's jump over onto the lathe. These are going to go in like this. Nice snug fit, because we don't want them falling out while we're doing the job. This one, I didn't realise the hole's a little bit tapered, so I'm going to put a little bit of parcel tape around here. So that'll go in there like that, and the parcel tape will just snug it up in the hole and stop the adhesive running down the gap. I've got a bit of 300 gram 12K carbon here. What I'm doing is I'm just taking out the individual toes from the woven fabric, because the part's so intricate that I just want individual toes to wrap around the features, and using the fabric as a woven fabric like this is just going to be too cumbersome. So the carbon is the first part of our composite, and the second part is our epoxy. This is a two-part product. You just mix it together. Well, when it comes out, you just mix it together, equal parts of each. The epoxy's job is to stabilise the fibres, to stop them moving around effectively. Now, a lot of repairs can actually be done just using this stuff on its own. A lot of people call this liquid metal, and it's really good stuff. But for this, because there isn't really a lot of space on the part, so I can't build up a big thick chunky block of the liquid metal, I'm going to put the fibre in there to help distribute the load around the part. Now just spread it out around the areas now that I'm going to be placing my fibres. That just gives the fibres something to stick down to. I'm just going to lay some fibres in. Press down into the resin. What we're aiming for is a high fibre to epoxy ratio. Now, if you're doing sort of pre-preg carbon and things like that, it's you know, you can get sort of 70% fibre to resin. Now we're not going to be able to achieve anything like that doing this method, but we want to be trying to get as much fibre in there as we can while maintaining full wet out. So basically all the fibres want to be fully saturated with as much glue as they can take without there being excess glue, effectively, because it's the fibre that gives it the real strength. Now this particular epoxy in itself is very strong, and like I said, can be used on its own for some repairs, but for this we want a little bit extra. So I want to make sure that all my fibres are overlapping the areas that I want to repair. Now the direction of the fibres, actually, there's quite a lot of sort of engineering goes into that. But generally, if you think about which way the loads are going, then that's the direction you want your fibres to be laying in, because the fibres will only transmit load in the direction that they're going. Think about it like a piece of string. It only works when you pull it tight. Normally you'd use a paintbrush for this with a laminating resin. I find it's a little bit easier with a chopstick when you're just dealing with these little short fiddly bits. So the first bit's quite tricky because everything's really runny, but once the epoxy starts to thicken up a little bit, it's much easier. Now you might have noticed this is a lot greyer now. And that's just because the first little bit that I got out of one of the tubes was the stuff in the tube wasn't mixed properly. So I've just given it a quick mix together on the part itself with some of the new stuff that's come out, and that's made it nice and uniform. So we've got a nice mix of epoxy that should go off properly. Because if it's not mixed properly, it won't cure. So this is starting to get there now. We're about 4 or 5 layers thick, and we've got some fibres running around this way, and then some of them run round and down and under the underside. We've got some coming up around circumferentially around this feature here, because if you think this bit here, where the screw goes in, it's failed because the screw's pushed out this way, so we want fibre running around the outside of here to strengthen that direction, and then around the outside here and tucking around underneath to stop this bit pulling off this way. And when you're putting your fibres in, what you want to try and do is get them so they don't all end in the same place, because if you think all the load goes along the fibres, if it all stops in the same place, you're going to get a concentration of stress in that location. So they all want to be distributed around and go in subtly different directions and end in different locations. So like this one comes down, ends over here, this one's going to come down, end over here. You know, I mean, it's not, no, this isn't precision engineering. This is, you know, kind of home workshop engineering. But as long as we follow the same basic principles of how the material works, there's no reason why we can't execute a decent repair. Okay, so this has been curing now for about an hour and a half, and the epoxy's still tacky, but it should be stiff enough for me to be able to remove these parts and it not all slump. So let's just take these out. It's a little bit wet still, but we should be okay. Let's pull that up there. There we go, that's one. This one might be a bit more tricky, but we'll see. Oh, no, it's coming. There we go. 2. I'll just use this to just pull this back into shape. There we go. Some of the fibres there. That's okay. This has had a couple of days to dry now, so a couple of little jobs left to do, and then we'll get this finished off. So just giving this a quick wipe over with a little bit of thinners, and that'll just take the stickiness away that's left on the resin. And then we can give this a sand over, prep it for paint, and by taking that stickiness away, it means we won't clog up the sandpaper. So I've just given this a little shape up with the file to make getting the screws in and out easier. And we'll hit this with some sandpaper now. Now you don't want to go mad with this, because if you start going in too deep, you'll start breaking the fibres, and you remember that the fibres are what's actually providing the strength to the repair. So we just want to take the shine off it, see how it goes kind of matte, goes this lighter colour when you sand it. We're just going to bring it to that sort of consistency most of the way over, and that'll give the paint something to key to. And the paint is just going to protect the epoxy from being attacked by the oils and things like that in the machine. Because if the epoxy starts to degrade, then the fibres will destabilise. You remember the epoxy is what's holding the fibres in place. So if the epoxy starts to break down, the fibres can start moving, and that's going to significantly weaken the repair. So the paint is just there to protect the epoxy, and the epoxy is there to both protect and stabilise the fibres. So there it is, the finished repair. If you'd like to see some more workshop related content, then please go and check out my channel, and thanks for watching.